Estimation of amount of FAS potentiometrically using standard potassium dichromate solution. Potentiometry is an electroanalytical method used to find the concentration of solute in solution. The principle of potentiometry is used to find the concentration of solution by measuring the potential difference between indicator electrode and reference electrode. Indicator electrode means whose potential changes with respect to change in concentration of ions, and reference electrode potential is fixed. E cell equal to electrode potential of indicator electrode minus electrode potential of reference electrode. Indicator electrode is platinum and reference electrode is calomel electrode. If you write the next equation, E cell equal to E naught minus 0.0591 divided by N into log of base 10 of concentration of product by concentration of reactant. In the beginning, the EM of the cell changes gradually due to change in the ratio of concentration of product and concentration of reactant. At the end point, the EM of the cell changes rapidly. So in this experiment, we have to estimate amount of FAS potentiometrically using a standard potassium dichromate solution. FAS means ferrous ions and dichromate is chromium 6 plus ion. So chromium 6 plus ion oxidizes Fe2 plus 2 Fe3 plus, and if ferrous ions reduces chromium 6 plus to chromium 3 plus, and you know that this type of reaction is called as redox reaction. If you write the next equation for this reaction, we will get E cell equal to E naught minus 0.0591 divided by N into log of base 10 of the concentration of Fe3 plus by concentration of Fe2 plus into concentration of Cr3 plus divided by concentration of Cr6 plus. In the beginning, the EM of the cell changes gradually due to change in the ratio of concentration of Fe3 plus by concentration of Fe2 plus. At the end point, the EM of the cell changes rapidly, that is due to oxidation of all Fe2 plus to Fe3 plus. According to this equation, at the end point, the concentration of Fe2 plus tends to 0 log infinity, and we don't know the value. That's why we can observe the large difference in EMF, and that EMF keep on changes. After the end point, the again EMF changes gradually, a very small change in EMF, that is due to the change in the ratio of concentration of Cr3 plus by concentration of Cr6 plus. We will provide FAS in 100 ml beaker, add 1 test tube full of sulfuric acid to maintain acidic medium, since potassium dichromate acts as strong oxidizing agent in acidic medium. Wash these electrodes. This is platinum electrode and this is calomel electrode with distilled water, and immerse these electrodes into this FAS solution and put this magnetic paddle to stir the solution. Fill the burette with potassium dichromate solution. Then switch on the instruments. Before addition of any amount of potassium dichromate solution, note down EMF. At 0, the EMF is 423 millivolts. In each step, we have to add an increment of 0.5 ml of potassium dichromate. At 0.5, the EMF is 438 millivolts. At 1, the EMF is 452 millivolts. At 1.5, the EMF is 468 or 69. At 2, the EMF is 496. At 2.5, the EMF is 'We are seeing the rapid rise in EMF at 2.5. So this point is called as the equivalence point. The equivalence point means the point at which the amount of titrant added is equal to amount of analyzing substance in the solution. At this point, all Fe2 plus ions are oxidized to Fe3 plus ion. According to this Nernst equation, the concentration of Fe2 plus tends to 0 will get log infinity. That's why we have seen the rapid rising EMF if the difference between the initial previous reading and current reading is more than 200 millivolts. Note down the values and continue the titration. After rapid rising EMF, take 4 more readings by adding an increment of 0.5 ml of potassium dichromate solution. At 3, the EMF is 854 or 55. At 3.5, the EMF is 861. At 4, the EMF is 865 or 66. At 4.5, the EMF is 870. At 5, the EMF is 874. Now stop the titration. First switch off the instruments, wash the electrodes and keep the electrodes in distilled water. Using this data, we have to find the equivalence point. To calculate equivalence point, we have to use derivative graph. For derivative graph, we have to find the values for change in EMF and change in volume. There is no change in EMF or difference of EMF for 0. Similarly for delta V. At 0.5, the change in EMF, the difference of EMF is 438 minus 423. At 1, the difference of EMF is 452 minus 438. So like this we have to calculate the change in EMF. The change in volume is 0.5, since in each step we have to add an increment of 0.5 ml. Then divide delta E by delta V, will get values for this term. Plot the graph of delta E by delta V versus volume of potassium dichromate. For 0, there is no value. At 0.5, so here is the point, put a cross mark and circle it. At 1, 1.5, 2, at 2.5, you observe the rapid rising EMF. So here is the point. At 3, 3.5, 4, 4.5 and 5. Now connect these points by free hand, then use scale to connect these 2 points, straight line, and one more straight line to connect these 2 points. Again these points by free hand. Now volume corresponding to maximum gives the equivalence point. So this equivalence point is used to calculate the strength of FAS solution. Then you have to calculate the amount of FAS present in the given solution.